and the HTML5 is actually in the next room. In the book, it is the room number is swapped. So I'm Hemil Shah. I'm a founder and director of eSphere Security and a key member in Bluenfi Solutions, a professional services company into application reviews based in India. I'm also on an advisory board for some of the companies like Security Exposure and whatnot. In the past, I tweet at eSphere Security. So pretty much the talk is going to talk. I'm going to talk about the how do you actually automate the mobile application reviews. So who doesn't have mobile apps today? Pretty much. Yeah. So if you look at the book, the smart storage scanning, the description about smart storage scanning is actually written in HTML5. So it is swapped. So the topics which I'm going to cover is actually written into HTML5, and the HTML5 stuff is over here. So it's swapped pretty much. Yeah, so so pretty much every company out there has a.
Headline is correct for your lecture.
Sorry?
Headline is correct.
The headline is correct. The component, the description is actually swapped. Yeah. Yeah. So who doesn't have the mobile apps today? Pretty much every company has a mobile app, or they are making one these days. So if you look at some of the industrial stats on which platform has been leveraged more, is if you look at this is in stats from IDC. If you look at the Android is pretty much leading the way with 81% of the devices today leveraging the Android platform, and then the following is iOS with 15.2%. So if we just sum both of this platform, it's pretty much more than 95% of the 95% of the coverage onto mobile platform. So then pretty much I can say you can just avoid the rest of the platforms, because then there are very less users on those platforms. The OWASP top 10 stuff, I'm not going to talk about the OWASP top 10 because there has been already a talk about OWASP top 10. But if we quickly look at the OWASP top 10, the insecure local storage has been leading pretty much almost 98% of the application has insecure data storage vulnerability. We do this consulting services, and almost we test like an 50 to 60 application a month. So from our stats, and we were part of the OWASP top 10 project as well. So from our stats, if you look at it, the local storage pretty much somewhere between 95 to 100% of the application we test, something is stored into the local storage. So you pretty much can see you pretty much can see that almost all application is storing data into the local storage. Then there is an information stored into the log file, which is shared between all the application. The copy paste, the privacy issue, the copy paste has been not disabled. We pretty much find it in almost like an 85% of the application. And then the cross-site scripting and the SQL injection has been discovered at lot of application as well. So let's look at some of the enterprise cases on what we have been finding. So this was a typical Android e-commerce application where the Android e-commerce application allows you to perform the transactions. So in this case, we found in credit card and private data information was actually stored into the local storage, but they were encrypting the file. Now, in Android, what they did is the encryption and decryption was happening on the client side itself. Now, the encryption key was actually part of the code, because he has to keep the developer has to keep the code, the encryption and decryption token in as part of the code. Otherwise, he will not able to encrypt and decrypt the stuff. So by decompiling an Android application, it was possible to get an encryption and decryption token, and then you can pretty much get an access to the file stored into the local storage. And then they were leveraging a web view control, so it was possible to perform a cross-site scripting attack onto Ajax, and then on the server side we found we did a SQL injection over a JSON. So pretty much if you look at all the attacks, so this is an example where it was a banking application. So your banking application would have a functionality which lets you see your past statements. Now your past statements are actually in a PDF format. So when the user actually clicks on past statements, the PDF gets downloaded, and then your application has to, your developer has two options. One is he writes the PDF reader himself, or he leverages the OS and give a control of PDF to that OS default PDF reader. Now, when the application actually hands over the control to the PDF reader, application doesn't know when the PDF has been closed. So there is just no way an application can remove that file. So here it was, and then your statement would have all the transactions information, your social security numbers, and all that information. So it was stored into the local storage, and then in iOS, the default behavior is to cache all the request and response in a file called cache.db. So the cache.db file actually had all the request and response, including your login request. So ideally, you should be removing the cache.db file as well. This was a social application. Lot of people leverages HTML5 these days for mobile to have a common code base for all the platforms, be it an Android or an iOS and whatnot. So this was an example where it was a social application, social media application which leverages and web view control on platforms, and it was possible to bypass, and this application had functionality that it only allows you to have it installed on one device per phone number. Now, it was possible to if you just copy the entire local storage from one device to another device, then entire account was actually replicated to another device, and then it was possible to leverage access the application on both the devices. So that pretty much hurted the company, because it was a direct financial impact to them, because now they were not getting money for every download. The screenshots were stored in a local storage, which is again in default OS behavior. On the presentation layer, it was possible to do a cross-site scripting and SQL injection, as they were leveraging in web view control, and they were sending that information in a plain text. They were not leveraging SSL. So if you do in postmortem, pretty much all the application had one vulnerability in common, which was a local storage. So, and then the server side and the logical issues were always hard to find, but it's always have the biggest impact, as we all know. Lot of time the question comes like, why the developer actually stores the information into the local storage? It's actually to provide an ease of information, ease of use for the user, or to gain in popularity. Or in mobile, everybody wants to achieve activity with a single click. Just a minute. Yeah, in mobile, everybody wants to achieve a stuff with a single click. So, and you want to achieve the decrease. You want to achieve you want to decrease the transaction time, and that's why you want to keep the information into the local storage. I'm not saying you should not keep the information in local storage, because the security has to always balance with the business requirement. And if you do not, if being a developer, if you do not store the information into the local storage, you are not achieving the business requirement. Security cannot overcome the business requirement. What information you usually find into local storage? The authentication credentials, the authorization tokens, your financial statements, your credit card number, your private information like your social security numbers, your social engineering sites, your Facebook and Twitter accounts, your owner's information, where I'm staying, where I'm living, and what is my phone number, and who is my wife, and what my kid's number is, and whatnot. And all the request and response which is sent from the client to the server in a typical iOS application. So if we look at some of the demo, uh, so this is an first example is where so this is an Android application where it's an e-commerce Android application which allows the user to perform in standard like an purchasing stuff and whatnot. So this is a bookstore. I'm entering my credit card number into the application. To perform the transaction. Now, being a user, when I do this, I don't know what's actually happening behind it, whether it's storing it or not. But if you go back and look at the application directory, the application directory actually contains a database file called info.db, which actually got the credit card information stored in a plain text. This is just an example where I'm storing the information in a plain text, but a lot of time we have seen an application which actually does a different kind of encoding or hashing the information before storing it. So, and that's why we have like a poor cryptography implementation in one of the OWASP top 10 list as well. If you look at the server-side exploitation from the mobile application, on the same application, when I click on the app, when I click on the any book, it actually is sending a JSON request. So here, if you look at the content length is 886. But then if I change the JSON to have or 1 equal to 1, I'm going to get all the results back. So now, if I hit go, the content length is 6,591. That pretty much proves that it's all the data. Now, a lot of time we get a question that XSS is not exploitable in terms of mobile. Now, here is an example how does an XSS can be exploited. So again, this is an HTML5 application where I have a search page which has the XSS. Now, you get a pop-up. Now, what I have done is I have written in a small node.js script. What I have done is I have written in small node.js script which actually reads the file from the local storage of that application. So I'm going to start the node.js script over here. So I started my node.js script, and then I'm going to inject the attack vector, which will send me the entire file onto my node.js server, which is running on a different machine. So it says client has been connected. Now if I go to test.txt, it has all the data which was stored from the local storage of that particular application. So with the XSS on the mobile, you can actually read the information from the local storage as well, which has probably the more impact than the web, where the user probably needs to click on the XSS link before you can exploit it. So what are the different threats? A lot of time the company says that we have MDM in place. We don't allow any jailbroken device or a rooted device from our MDM. Or we have strict policy enforced through an MDM which does not allow user to jailbreak the device, or which forces user to have a password protection. Now, so the questions are, what attacker can do? What attacks are we talking about? The privacy, it is mobile. At the end, the mobile device is prone to be a mobile. So the different exploitation scenarios are, first of all, the physical theft. in just last 1 year, there has been more than 1 million instances in just United States where the smartphones were stolen. The temporary physical access, even I can get in access to your device for 5 minutes on an iOS device. I can get the data using a tool called iPhone Box, or in an Android, I can just install ADB over Wi-Fi to get in to access your device remotely. You have a lot of malware and malicious application, and just in a recent study performed by an Virginia Tech University. Google Marketplace itself has like an 8% of the application which does a malicious stuff. It's the lack of standardized security review process. It's like I'm going to talk about this as well. And then there is always a chance that the attacker can jailbreak the device if he gets in physical access to it. What are some of the other challenges? It's a review process. We all know that Apple reviews their application before coming into App Store, but do we know what exactly they look for? We don't know. It's not transparent. It's very time consuming as well. So let's say I'm a developer and I have found a vulnerability. Now I have fixed it, and then I have to send it to Apple so that Apple can release it. That particular fixing the vulnerability and sending it to Apple and releasing it takes actually good 3 to 4 weeks of a time. Google just recently started it. Google recently started reviewing the application, but again, the problem is same. It's very hard to catch up for them because there has been already more than 1 million application in Google Marketplace. Not possible in BlackBerry at all, because BlackBerry actually has started that they will natively support an APK files. So now you can use any application from Google Marketplace on your BlackBerry devices. So how does an BlackBerry is going to control what applications have been reviewed or not? They probably don't have any control over it. The another challenge is actually frequency of updates. If we look at the pretty much on the web front, if you look at the life cycle of web application release, it's either 3 or 4 releases a year in terms of web application. If you look at the mobile application release cycles, it's very fast. If I show you some of the stats, this is the stat for 2013 where Facebook, so I don't know whether you guys can see it or not, but Facebook last year had like 19 releases for iOS and 34 releases for Android. JP Morgan Chase Bank had like 9 releases for iOS and 2 releases for Android. eBay had 9 and 4. Amazon had 10 and 3. So pretty much if you look at and WhatsApp has like 24 and 54. So pretty much every 4 days you have a new version of WhatsApp in Android. So if you look at the release cycle, it's so much higher compared to the web application. It's even tough for any company to review the applications during that time, or review the entire application or even a partial of the application, because the pen tester will find the stuff, then the developer needs time to fix it and all that. When we are looking at even just 10 applications, pretty much you are talking about every release a month. So how do you review the Android application? Android natively supports like 3 types of storage: the internal storage, the external storage, and the storage in a shared preferences. The internal storage is basically as part of the data directory itself. The external storage is storage into the SD card, and then there is something called shared preferences. Now shared preferences is actually a file which is shared which can be shared with different application if the other application has permission to access it. How to test? Is it very hard to test an Android application? It's very time consuming, because typically when you are doing a manual review in terms of any Android application, what you need to do is you need to capture the different state of the application. So you install the application, take the state. Then you open the application, log into the application, take the state. Then you perform another feature of the application, you browse through another feature of the application, you take a state. and then you log out the application, you take a state of that, and then you close the application and you take out the state of that. And then the one has to compare each of the state to find out what has been stored at what functionality or what level into the application. So if I can show you that, so this is an Android application I'm trying to perform an review called internal storage demo. So I go to that directory. I do ADB pull, so I just install the application and took a state back of that particular directory. And that has the token file which has the value 28782. Now, so this is like you're copying everything and then you are reviewing stuff, and then you open the application. Take a backup of this, say backed up. Then you open the application again and do an ADB pull again. So now I enter the credential and log into the application. I have to do an ADB pull again to get the dump of after login. And now you start observing the data. Then you need to, so let's say my application is 10 different functionality, then I have to do this 10 times, and then I have to compare each of that to come up with a conclusion whether the application is storing information into the local storage or not. It's very time consuming. It's tedious. It's very tedious. It's not human who would do it accurately every time. It's prone to be false positive because if you're doing it repeatedly 10 times or 15 times based on the functionality of the application, you will end up overlook some of the information, and you will not find stuff which is there into the local storage. So can we automate this? Yes, in terms of Android actually provides you an API to monitor the file system. How many of you have used like an FileMon? A classy FileMon tool from sysinternals was very handy when you're testing a desktop application. Similarly, we have written a tool called FSDroid. It leverages an SDK. No hacks, nothing is required. It's an SDK code. You install this application. It monitors the file system. You can write filter on what directory you want to monitor. You can save your last 5 reports. You actually don't need a mobile device at all. You can run it in an emulator as well. And it's very easy to run. You just hit in one click. That was the previous version. The new version, which I'm launching along with this talk, if you go to the website, you can download it. So earlier, one of the challenge was, a lot of time the application creates a new directory at the time of run. So when the application is running, if it was creating a new directory and storing the information as part of the new directory, the tool was not finding it. The new version now finds it. And then the permission has to be assigned manually in previous version. Now the tool actually, you just select the application and the tool will assign a permission to that directory. So let's look at an FSDroid in action. So on the left hand side, on the right hand side, you have a previous version where I'm, let's say, monitoring the bookstore application. Before I hit start, I have to assign a permission. So here you can see that there is no permission for com.bookstore. Just to make it easy, I just assign like 777. So now now everybody has the permission to look into that directory. You fire up the FSDroid again, and then you just hit the start button. Now if I minimize this and then fire up the bookstore application and perform the different operation in bookstore. Now if I go back to FS Droid, it will show you what directories it has opened and what directory it has closed. So now you know where to look for the information. Now in the newer version, we have simplified this. So in the newer version, when you launch it, when you go to config, it shows you the list of application. You just select the list of application and it assigns the permission. You hit the start button and then perform the operation. It will now actually show you which file has been modified as well. So this is an improvement into the engine where over here, if you look at this, it shows you that this file under data com.bookstore cache, WebView cache, Chrome staging is closed without any write. So now you know that application is modifying or writing into which file. So that is the, now it's more like an complete file monitoring rather than just giving you the hints. In terms of iOS doesn't provide you any such APIs to monitor the file system. So we came up with a different idea. iOS basically have like two type of storage, internal storage and the keychain file. Nothing new than Android. Pretty much you just go through the different files and directories and to find the information, and that's all the methodology is for the manual review. So on a non-jailbroken device, the methodology is something different. So if I show you a manual testing for the iOS, it's more like this is a DVD store application where I'm storing the information. So it's on a jailbroken device, it's pretty easy. You SSH into the device and then go through the directory and find the information stored into the local storage. So I SSH into it and then go to this application directory, find the stuff. And on the non-jailbroken device, what you need to do is there is a utility called iFunBox. So here, I'm leveraging an iFunBox to dump the data. iFunBox actually can dump the data even if the device is locked as well. So over here, you can say that the test iPod has been connected and it shows me the list of the application installed into my iPod. And then, first of all, I install the application using an iFunBox. So the application has been installed. So now, if I click on that application directory, it will show me all the directories and files. You can pretty much copy the files from the directory or open it right there to find the different information stored into the local storage. Now, so now you don't need a jailbreak device to even perform a security review. You can leverage the iFunBox to get an access to the local storage. Can we automate this? Answer is yes, using an iApplyScan. The current version of iApplyScan requires a jailbroken device because it actually connects to the device while performing an analysis. The existing feature, the previous version's feature is it can look for a sensitive information. It can tell you whether the particular file exists or not on a particular directory. It can download the file if you want for a further analysis, and it can run any third-party external binaries like a keychain dumper or anything or a cookie.binary cookie file to get an output of those third-party tool. The new version, actually, we added the poor cryptography detection. So now, if your target application is storing the information using any encoding mechanism or a hashing mechanism like a base64 hex, URL encoding or HTML5 or JZip, or in terms of hashing it, if it is leveraging MD5, SHA-256, SHA-384 or SHA-512, iApplyScan can detect it. And we have added a feature called load and save configuration for the future use. So if you look at the iApplyScan, so you enter the credentials, it connects to the device. You select the application you want to review, and then select the location where you want to download the files. Enter the text which you want to search for. If you want to look for any particular file, if you want to see, let's say, whether the database file exists or not and whatnot, you can enter that and then hit run. That will show you all the data. So this is the previous version. Now if you look at the newer version of iApplyScan, the newer version has more features. So now you connect to the device. You connect to the device, select the application name you want to review. Same, select the path where you want to download the stuff. Next, enter the text you want to look for. It also supports the regular expression, so you can enter the regular expressions as well. Select the encoding and hashing mechanism you want to test for. And then if you hit run, it's going to find all the information. So from the previous one, this application actually stores base 64 encoding, so it was not finding the word JIL, if you have observed the last time. Now it has been finding the JIL has been stored into one of the file as well as base 64 encoding text. So now you know that the application is doing two things. One is leveraging the poor cryptography because they are encoding the stuff rather than encryption. And then you also know that this particular information has been stored locally. So now I'm gonna, let's say I want to use the same config file, the same configuration for multiple scans. I can enter all the details and then save it for the later purpose. So there is a feature called save config. So let's say I want to just test that encoding. I don't want to try all hashing stuff. And then before running, there is an option called save config. So if I hit the save config option, it stores the information into the XML file. And then if I open the iApplyScan again, it lets me load the config. All the information would be there. So this pretty much becomes like a routine for my reviews, where now I don't have to enter all the text and everything again. All I do is load config. So if I just load the config, all the information would be there. So with both of this tool, we are trying to cover 4 different OWASP top 10. Insecure data storage, security decision via untrusted inputs, broken cryptography, and sensitive information disclosure. So out of 10, 4 of the OWASP top 10 attacks can be tested with this tools. The tools can be downloaded from our website, espheresecurity.com/resource tools. The other tools called dumpdroid, check debuggable, and an app code scan, which is in like a semi-automated manual, semi-automated code review tool. You can find that as well. Uh, any questions you have? Sure.
Thank you. It's switched off if you want to switch to.
Is it on? What are the benefits of knowing where the data is located?
So when you are doing a penetration testing, one of the checks is what information has been stored or at what places, because you are testing for the what risk you are exposing from your application. So as part of the testing, you would perform a test against what information has been
What
stored
an
where.
attacker can do with these?
Sorry?
What an attacker can do with this information?
What you can do with this information?
The
Like,
attacker.
what attacker can do, that really based on the information you find. Let's say
Yeah.
in your cache.db I found an username and password.
As far as I know, only the application that created the data has access to them in the Android.
Yeah, so that's why there were, I don't know whether you look at the slide or not, there were slide how the attacker can exploit it. So let's say I'm an attacker and you are a normal user. Let's say I get an access to your phone for a temporary purpose, let's say for a 5-minute or a 10-minute. I can hook that to my phone or hook that to my laptop, get all the data out of your phone. You won't even notice that, and I'll give your phone back. And then I can use your information to become you.
Oh. Yeah, that's rather rare. I
Or,
think.
so that's one of the case. The another case is, let's say your phone is stolen. I get a permanent access to your phone.
It's a rather rare occasion, I think.
Sorry?
It's a rare occasion, I think.
It's very rare case, you think?
Yeah.
Okay. Then the number is pretty high actually in terms of smartphones. Very high compared to the classic phones. So you are pretty much questioning whether we should be worried about mobile application security or not. Because if the attacker cannot exploit it, why should I worry about it?
Yeah.
Yeah, so in terms of Android, let's say I don't need an access if you are using an Android device. In the recent study, there has been 8% of the application into the marketplace itself, which has the malicious activity. So let's say you have some application, you install some application from marketplace itself.
I just thought that the other applications, malicious applications, don't have access to the data that the other application wrote. That's what I thought.
Sorry, I didn't get your question. Yeah.
I thought that malicious applications don't have access to read the data of the other applications.
But there are certain areas of the application. So let's say a pasteboard is shared amongst all the application, or there is something called shared underscore preferences directory.
Only where they share them.
Sorry?
So it's exploitable only where they share this information via their shared directory.
OS itself, yeah, to root your device, yeah.
This way, yeah.
Or let's say you have a copy paste enabled into sensitive fields. Now when you hit the copy button, that gets written into the pasteboard, which is shared among all the application. A malicious application can just monitor the pasteboard to get an information to all this access, to get an access to all this information. Similarly, in Android, there is something called shared prefs directory. Now, if you store something into shared underscore prefs directory, there are 3 different type of permission. And the worst thing is, by default, the permission is allow all. Ideally, allow none should be the permission, but by default, the permission is allow all. So if you write anything under shared underscore preferences, and if you do not assign permission to it, then every other malicious application can read that data as well.
Thank you. I got it now.
Yeah. Sorry? 5% physical theft everywhere in the world.
I was going to say that's a lot of smartphones, if you think about it. Now, my question is more related to the data. You said some applications don't know when they've closed, so that they don't actually tidy themselves up. Does your tool do anything looking at how long that data resides with, some applications may be a bit more savvy and actually clean themselves up afterwards. Does your tool look at how long that data resides in the local storage? So, it may write a piece of information, then 30 seconds later get rid of it after it's been used? Or does it just assume that it's just looking for written once and then just doesn't look at what it states afterwards?
No, so current version does not do it, but that is the feature we are developing as we speak.
Okay.
Yeah. For iOS. In terms of Android, yes, it does, because Android is pretty much the FS Droid is a file system monitoring. So when you're actually going to delete it, it is going to capture the event that, okay, you have deleted this file at this particular time as well.
Does that tie it back to the original application that launched it? Because obviously you could have a malicious piece of software that says, hey, I've just got that piece of information, then deletes it from the original application that was using it.
Yeah, so it actually does it for the directory you choose to do it. So when you actually fire up this FS Droid, it prompts you what directory you want to monitor.
Right.
And then if that malicious application is doing it as part of that directory, then yes, it will do it.
Oh, okay.
Yeah.
Got you. Cool.
Could one solution to the problem be that every time a mobile app writes to a data store, it encrypts, and every time it reads from that data store, it decrypts, so any malicious person wouldn't be able to make sense of it? Was it just making life too complicated?
In which platform you are doing it, that's a good question, because in terms of iOS or an Android or for any mobile platform, it would be possible to get your encryption and decryption string. So the current solution for which we give it to our customer is, what you do is and we are not saying you do not store the data. You have to store the data because that is what the business requirement is. Now, you do not store any private or a sensitive data like in credentials. And even if you want to do it, what you do is you store it encrypted. Do not perform any decryption on the client side. Take the encrypted data, send it to the server, because whenever there is a login, you need to validate with the server. So take the encrypted data, send it to the server, let the decryption happen on the server side, validate the authentication, and then come back. If you perform both encryption and decryption on the client side, that's when the problem starts. BlackBerry, yeah. Sorry? Yeah, so yeah, pretty much the behavior is almost same. In terms of Windows, I think although the stat says 2%, if I look at the review from the review perspective, I would say if we are doing like a 50-55 application review a month, we see like 1 or 2 applications, maybe 1 application which is a Windows application. But there has been effort onto the Windows mobile application development as well. So they are catching up. The other category is more like a smart TV application, let's say. Samsung Smart TV has an ability to write an application. Your LG has the ability. Sony has the ability. Then there are like devices like Roku devices and Hulu devices and whatnot in US. All those will fall under the other categories. All right, thank you guys. Thanks.